Okay, so I'm going to do some simultaneous equation questions from my iMaths. So it's the exercise Simultaneous Equations 2, and I am going to do question 1 in this video. So that's 5 different simultaneous equation problems. So I'm just going to switch to my pad there. So the first question was 3p plus 2q equals 27 and 7p plus 4q equals 59. So that's two equations that belong in a pair together, and I'm going to label them as 1 and 2, equation 1 and equation 2. And our job here is to try and find a value of p and a value of q that works in both of the equations at the same time, simultaneously. So what I'm going to do first, I noticed that 2 goes into 4, so I've got a 2q and a 4q in the different equations. So if I take everything in equation 1 and multiply it up by 2, so 3p times 2 becomes 6p, 2q times 2 becomes 4q, and 27 times 2 becomes 54. So that's equation 1, but I've multiplied everything up left and right by 2. I've done the same both sides, so it should still balance. And then meanwhile, equation 2, I'm not doing anything to that at the moment, so that's going to remain as 7p plus 4q equals 59. Now the reason I did that was so that I had two equations that both had the same amount of q in them. So I'm going to call those equations 3 and 4, even though equation 4 is exactly the same as equation 2 was before. And now what you can do with simultaneous equations is subtract whole equations from one another. So in this case, I'm going to do everything in equation 4 minus everything in equation 3. I'll draw a neat little line under there. So I'm going to do 59 minus 54 is 5. 4q minus 4q, well, that's nothing, so that's going to disappear. And then 7p minus 6p just gives you 1p, which you can just write as p. So p equals 5. So we've actually managed to eliminate the q and figure out that p equals 5. Okay, so now that I've figured out what p is, I'm going to take that value of p and substitute it into equation 1 that we started with. So equation 1 was 3p plus 2q equals 27. And now that I've figured out that p is 5, that's going to become 3 times 5 is 15. 15 plus 2q equals 27. And I want to figure out what that q is. So 15 plus 2q is 27. I'd quite like to get the 2q bit on its own. So I'm going to take away the 15. But because an equation is like a balance, I've got to take away 15 the other side as well. So that leaves me with 12. So taking away 15 from both sides, 2q equals 12. I don't want to know what 2q's are. I just want to know what q is on its own. So I'm going to divide everything by 2. So when I divide the right hand side by 2, I get 6. So q equals 6. So I figured out my answer, that p equals 5 and q equals 6. It's always a good idea to check your answer by putting it in the other of the original equations, equation 2, and making sure everything still balances. So 7p plus 4q equals 59. So 7p is 7 times 5, which is 35. 4q is 4 times 6, which is 24, and that's supposed to equal 59. And 35 plus 24 is 59, so we know that we've got that one right. So I'm going to go over to the iMaths now and just fill that in. So P equals 5 and Q equals 6. And then the next question is 2s plus 3t equals 14, 7s plus 9t equals 46. So I've already managed to write that down on my pad. So let me just flick to the pad again. There it is. Just going to put a sheet under there so that my pen doesn't go through the page. Okay, so this time, again, two equations, label them 1 and 2. So 2s and 7s in the equations, and then 3t and 9t. Now I notice that 3 goes into 9 3 times. So if I take everything in equation 1 and multiply it by 3, then I'll get a 9t there. So taking everything in equation 1 and multiplying it by 3, so 2s plus 3t equals 14 becomes 6s plus 9t equals 42. So that's just everything there in equation 1, but I've multiplied it by 3. And because I've done it to the same side, because I've done the same thing to both sides, then it still balances. Meanwhile, the other equation is as it was before, 7s plus 9t equals 46. I'm going to call those 3 and 4, even though one of them was exactly the same as before. And because of what I did, I've got the same amount of t in both. I've got 9t in both of them. So what I can do is subtract whole equations from one another to eliminate that t. So I've noticed I've got 7s on the bottom and 6s on the top. So I'm going to do the bottom minus the top. So that's going to be equation 4 minus equation 3. Equation 4 minus equation 3 gives me, so 7s minus 6s just gives me 1s, s on its own. And then 9t minus 9t gives me nothing, so it disappears. And then 46 minus 42 is 4. So I've figured out that S is 4 by having eliminated t. Okay, having done that, I'd like to figure out what t is. So I'm going to take that value of s equals 4 and substitute it into my original equation 1. So my original equation 1 said that 2s plus 3,2 equals 14, but now I've figured out that s is 4, so 2s becomes 8. 8 plus 3t equals 14. And now I've got to figure out what t is. So 8 plus 3t equals 14. I'd quite like to get the bit with t on its own, so I'll take away 8. I've got to do the same the other side because it's like a balance. So I get 3t equals 6. I just want to know what a single t is, so I'll divide everything by 3, and that gives me that t equals 2. And then finally, it's good practice just to check that your answer works. Check it in equation 2, the other one. So equation 2 was 7s plus 9t equals 46. So 7s is 7 times 4, which is 28. 9t is 9 times 2, which is 18. So 28 plus 18 does equal 46. So we know that it works. Notice the neat vertical alignment of everything. Equals lined up, t's lined up, s is lined up. So try and emulate that if you can. Okay, so I'm just going to go on to my iMath there and fill in the 4 and the 2. Okay, so next question, 2a plus 4b equals 44 and 8a plus 5b equals 88. I've already written that down on my pad on the next sheet. So let's get on to that. Okay, I think I'll go a little bit faster this time. You can always play back the video if you're a bit unsure. I'm going to label the equations 1 and 2. I've got 2a and 8a. I notice that 2 goes into 8 4 times, so if I take everything in equation 1 and multiply it by 4, instead of 2a plus 4b equals 44, I get 8a plus 16b equals 176, I hope. And then meanwhile the other equation stays the same. 8a plus 5b equals 88, and because I multiplied the first equation up, I've now got the same amount of a in both equations. So they're a pair that have got to be solved together. I'll call them 3 and 4. And if I do, I'm going to do this time everything in the top equation minus everything in the bottom equation. So this time I'm going to do equation 3 minus equation 4, top minus bottom. Now the reason I've done that is I've spotted that I've got more b's in the top than in the bottom, so it's going to come out nicer avoiding minus negative numbers if I do the big thing minus the small thing. So 8a minus 8a disappears, 16b minus 5b gives you 11b, and 176 minus 88 in fact is 88. So 11b equals 88. I just want to know what a single b is, so I've got to divide everything by 11. Do the same on the other side. 88 divided by 11 is 8. So b equals 8 is my first answer. And then I'm going to take that value of b that I found out and I'm going to substitute it into my original equation 1. Equation 1 was 2a plus 4b equals 44. I've now figured out that b is 8, so that becomes 2a plus 4 times 8, 32 equals 44. 2a plus 32 equals 44. I want to figure out what a is. I'll get the a bit on its own by taking away the 32, but I've got to do the same the other side as well. So taking away 32 both sides, I get 2a equals 12. I just want to know what a single a is, so I'm going to divide by 2. I've got to do the same the other side, so that gives me a equals 6. Final answer, a equals 6. And then just to be sure, check it in equation 2. So equation 2 was 8a plus 5b equals 88. 8a is 8 times 6, which is 48. 5b is 5 times 8, which is 40. So 48 plus 40 does equal 88. So we know that we've got that one right. So I'm just going to go over to iMaths and fill that in. Click to that there, if I can figure out my fancy schmancy editing software here. Okay, so 6 and 8 were the answers to that. And then the next question is 5m plus 6n equals 83, 15m plus 4n equals 137, which I've already got on my pad, I hope. There it is. Okay, so I want to multiply up either something to make the m's the same or something to make the n's the same. It doesn't really matter, except that I notice that 5 goes into 15 3 times. So if I just multiply up everything in equation 1 by 3, then I'll get a 15m there instead of a 5m, which is the same as the m I've got in the other one. So let's do that. Everything in equation 1 times 3. So 5m plus 6n equals 83. It's going to become 15m plus 18n equals, just quickly do that in my head, 249. So that's multiplying everything in equation 1 by 3. And then I'm going to leave equation 2 as it was. So that's 15m plus 4n equals 137. So I've got another pair. I'm going to call those 3 and 4, but this time they've got the same amount of m in them. So I can do everything in, let's go everything in equation 3, take away everything in equation 4, because I've got bigger numbers on the top than on the bottom. So 249 minus 137 is 112. 14n minus 4n is going to give, 18n minus 4n is going to give me 14n. Brain working a little bit ahead of my mouth there, or vice versa. And then 15m minus 15m is just going to disappear. So we've eliminated the m's and we've reduced it to one equation in one unknown thing. 14n equals 112. I just want to know what a single n is on its own, so I need to divide by 14. So I need to do the same on the other side as well. 112 divided by 14. Quickly doing that in my head, that's 8. So n equals 8, having divided both sides by 14. So now that I've figured out what n is, I'm going to take that value of n and substitute it into the original equation 1. So equation 1 was 5m plus 6n equals 83. Now I've figured out that n is 8. That becomes 5m plus 6 times 8 is 48 equals 83. So 5m plus 48 equals 83, and I want to figure out what m is. So I'm going to take away the 48 to get the bit with m on its own, but I've got to do the same thing the other side as well. So 83 take away 48 is that 35? Let me just double check that in my brain. Yep, 35. So 5m equals 35. I just want to know what a single m is on its own, so I've got to divide by 5, and then I need to do the same the other side as well. So dividing both sides by 5, I get m equals 7. Always a good idea to check that. So in equation 2, which was 15m plus 4n equals 137, I'm going to take those values that I just figured out. So 15m is 15 times 7, which is 105. 4n is 4 times 8, which is 32. And 105 plus 32 is indeed 137. So we know that we've got that right. Okay, so over to the iMaths page to fill that in. 7 and 8. What am I doing here? 7 and 8. And then the last question is a word problem. So 8 balloons and 3 cakes cost $18. So I'm going to call B the cost of 1 balloon and C the cost of 1 cake. So 2 times the cost of a balloon plus 3 times the cost of a cake makes $18. 2B plus 3C equals 18. And then the second piece of information, 6 balloons and 4 cakes cost $34. 6B plus 4C equals 34. So back to my pad where I've written that down already, I hope. Or possibly I haven't. Oh, there's a funny thing, I haven't written it down. So let's just go back to iMaths and write it down. So I've got iMaths on my screen. You can't see that, can you? 2b plus 3c equals 18. So 2 balloons and 3 cakes cost $18, and then 6 balloons and 4 cakes cost $34. So that's that. So that's a pair that's got to be solved together. I notice that I've got 2b and 6b, and 2 goes into 6. So if I take everything in equation 1 and multiply it by 3, then instead of 2b plus 3c equals 18, I'll have 6b plus 9c equals 18 times 3 is 54. And then meanwhile equation 2 is going to stay exactly the same as it was. 6b plus 4c equals 34. I'm going to call those two equations 3 and 4, and then I'm going to subtract the whole equations, a whole equation from another whole equation. I'm going to do equation 3 minus equation 4, equation 3 minus equation 4, so that I get 54 minus 34 is 20, 9c minus 4c is 5c, and 6b minus 6b is nothing, so it disappears. I've eliminated the b's, and I've got 5c equals 20. I just want to know what 1c is on its own, so I'm going to divide everything by 5. So doing that on the other side as well, 20 divided by 5 is 4. So having divided both sides by 5, c equals 4. I'm going to substitute that into my original equation 1, which was 2b plus 3c equals 18. So I figured out that c is 4, so that's going to become 2b plus 3 times 4 is 12 equals 18. 2b plus 12 equals 18. I want to figure out what b is, so I'm going to try and get the bit with the b on its own, take away the 12, but then I've got to do the same the other side as well. So 2b equals 6, having taken away 12 from both sides. I just want to know what a single b is, so I'm going to divide everything by 2. Got to do the same the other side as well. So dividing both sides by 2, b equals 3. So I think I've got my answer. B equals 3 and c equals 4. So what was that? Balloons and cakes. So balloons $3, cakes $4. But I'm just going to check that in equation 2. So equation 2 was 6b plus 4c equals 34. 6b is 6 times 3, which is 18. 4c is 4 times 4, which is 16. And 18 plus 16 does equal 34. So we know we've got that one right. So b equals 3, c equals 4. Going back over to the iMaths. So b equals 3, the cost of one balloon is $3, and one cake is $4. That's pretty expensive for balloons. They better be good. Okay, so let's mark that, and lo and behold, 12 out of 12, very satisfying.